Welcome to this webinar or mini class on the last day of the Hepatica week. My name is Bente Lilja. I'm an earth scientist and a nature-loving gadget geek, and I am very happy to present to you the last day's program. We will be looking at how we can combine the data that we have collected with our mobile app, the My Seasons, for instance, or any other app that or gadget that you might have used during this week to collect data. We will see how we are organizing or how we can organizing this data in data models, and we will also see how learn how they can be made so-called interoperable. It means simply that we can combine the different types of data with each other and then produce new knowledge. So we will learn that first, and once we have done that, of course, we can start to use our data. And we have Christian Hüttich, from one of the developers of My Seasons, and he's going to use this data in climate change research, and he will explain how we are going to do that. So that's the two presenters starting now at 6:30. But then the secret link between the Hepatica nobilis or liver leaf or Leberblümchen or blåveis and space will be revealed later this evening. Dag Anders Mollestad from the Norwegian Space Agency will be on around 9 o'clock local time. So that's 9 o'clock Central European time, 7 o'clock UTC. So, but first we will start with Arne Jørgen Berre, who is then going to talk about data modeling and making data interoperable. So I think we can just start. Arne, you can start by introducing yourself.
Yes, thank you, Bente. So my name is Arne Jørgen Berre. I work for SINTEF Research Institute in Oslo, Norway, and has been involved in international standardization on geospatial data since the mid-90s, 1995 approximately, I think, when the Open Geodata Consortium started in parallel with ISO TC211. So in particular on the standard on the conceptual modeling of all of the data models within the ISO TC211 community and OGC based on UML models and encoding into XML, as well as the service architecture. And lately I have been involved in citizen science and citizens observatories with the citizens projects on air quality. And that's the context for our common work on a joint data model for interoperability among citizen science observations. So that's the context, and I have a few slides I can present on this, if you provide me with the opportunity of the screen, Bente.
You can provide yourself with that screen. It's a green button up to the on your left-hand side if you put the cursor on.
Exactly. So here we are, and let's see there.
While you are doing the okay, you're ready? Okay, here we go.
Here we are. Okay, so I'm going to talk about both models and data models for interoperability for citizen science. And I'll give an introduction to the concept of citizens observatories in citizen science with the Citizens Project as a basis, and the work we do on an interoperability reference model for citizen science, which is rooted on the European Interoperability Framework, ISO-NIST Big Data Interoperability Framework, and reflections we have done in these projects, and also relationship to work in the GEOS context and the European Citizen Science Association. So that's the topic I will touch upon. And I'll start to mention that we have currently a set of projects, Citizens for Air Quality Monitoring, development on sensor-based Citizens Observatory for improving quality of life in cities is the one I'm working on. You see down to the right here other projects we heard earlier from Cobweb and OGC participation with BART in this series this week. We have
Ar
also,
Arne,
yep,
sorry
yes,
to interrupt, but I think we are just seeing your first slide on the screen. So I think you have to
okay.
change to the to a different mode of.
Yes, okay, it's because I was changing my slides and you don't see that. Let me see how I can do that. Change it in a different way, perhaps, if I can share my whole screen in a suitable way. Let's see how to do that. Let me share my entire screen. Okay, so do you see my whole screen now?
We see still a video. So I think you have to open a different window and then put your presentation there in presentation mode.
Okay, let me see there. The right one stored here.
Now we see it. Well,
Do you see it now?
we see several screens.
Okay, and now you see
There
mine?
yes. Yes.
Okay. Okay, so let's stay on that one.
Okay, here we go.
Now you should see on the lower right-hand side the number of project names, which are the 5 citizens observatory projects that have been running in Europe for the last 3 years, and are going into the last year. Some of them finished already, but Citizens and vSensit and Cobweb is still running. And we are now looking at common technology aspects for future activities. I represent the Citizens on air quality. We heard also Cobweb working on biodiversity and aspects related to observations in nature, which is very relevant for the Hepatica week. But what's been pointed out during earlier session this week is that there is a lot of commonalities if you look now into the interoperability aspects of these systems that are supporting our activities. So what we see here is the Citizens platform, and on top we see basically a common structure or life cycle that starts with managing all of the resources, the citizens or the humans, the sensors, the data and the services we have. And the main focus is on observations, static or mobile observations, also dealing with surveys with questions. And then the process goes further on to publish or make this observation available, doing discovery of these, and also doing various kind of analysis, validation and verification, and doing something further based on it. So what we typically have is a situation where there's a lot of different input opportunities, mobile apps, but also web portals with surveys and questionnaires, also static sensors or mobile sensors that are interacting to provide additional information for the observations, and then storage facilities, where we have a special data service platform in Citizens that use OGC standards, WFS for storage of observation, and provide the output of this in different ways, including linked data. And then we are looking into how to make all of these resources available in the GEOS common infrastructure for relevant resources about environmental observation. And this is a common, pattern that we have in a lot of these activities that we are talking about this week. There are differences in terms of the actual implementations of this, but the principle is common. So based on that, we have looked into a kind of common citizen science reference model, trying to identify the common aspects and what we can share, and how we can also support interoperability in terms of sharing the outcomes of observations for various purposes. And for this, this reference model puts a kind of broad context on what we are doing with an overall information value chain based on the life cycle of observation, related to ISO 19119 standard, where I have a responsibility, and also Inspire for spatial data infrastructure. And then adopting concepts from the European interoperability framework, looking at various aspects of interoperability with the lowest level of technical interoperability, and also linked to non-functional aspects. So I'll say a few words about this, and starting out with the overall life cycle that we have from earlier work in Inspire and ISO 19119, and bring this into the context of this Hepatica week, where we will look into observations of flowers, which is the focus of the observations. But the general aspect we have is that we have some way of managing, want to complete this first of all, managing observations, registering users, the discovery observations, viewing observations, and making these available for various kind of analysis purposes. So with this perspective that we will go from observations being done to being managed and identified, we can look into the broader concepts of interoperability, which means resolving the issues when we want things to work together. And it's not only data that will interoperate, but it's the wider context. So we need also to look into the political context of why do we want to have interoperability, the legal aspects of interoperability with laws, and also with ownership, and with issues dealing with privacy. Part of this is organizational interoperability. What are the agreements between organizations and individuals? Semantic interoperability, dealing with the meaning of things that we are interchanging. And technical interoperability, how do we do this from a technical implementation point of view. So this European interoperability framework is a nice broader context when we talk about interoperability. And we need actually to address all of these levels in a broad context. From the technical point of view, we can look at the ISO 19119 service architecture model, which is also used in OGC, with a number of topics that we need to address if we look into the technology aspects of interoperability. We have put it into the context of citizens observatory elements, and we talk about boundary and interaction services, which are where the sensors and the user interfaces comes in. We have the data and things sensor management services, dealing with data management, where is the main data model is residing. But they have a purpose of being processed, so also the processing services is related to this, and the workflow combination of various services with composition and orchestration services, and this is related again to communication management and security services. So all of these are elements that we need to look into when we talk about interoperability from a technical point of view. There is a similar activity in the current popular buzzword area, I guess, on big data. Here is from the ongoing work with ISO and US National Institute of Standards for a big data interoperability framework. And what's interesting is that we can recognize the same kind of information value chain model here, from data collection, observations in our case, preparation and curation, analytics, visualization, and access. So it's the same life cycle philosophy as we have from Inspire and from the ISO work. And we have an underlying description of data management support, from physical resources of data storage, different kind of data representations, batch interactive or streaming handling. So citizens science and citizens observations fits into this framework. And we can follow some of the same principles and also some of the same supporting standards which will evolve from this work. So up to the left here we have the common view of collection, preparing, doing analysis, visualization of access to observations. So from that perspective, we have tried to look into the reusable elements for interoperability for future projects, also in the Citizens Observatory projects, and started the work on the Citizens Observatory Toolbox, where the most important parts here is the joint collection of data of different kinds and the storage point into data. So we can gather observation from mobile apps, also activities on doing surveys with questionnaires, handling data from sensors, and then doing the presentation of the data into user interface widgets and portals, and also have methods and guidelines and analytics for how to process the data. So what we are looking at is all of these different elements with respect to finding common facilities, and for interoperability, with the core focusing on the data, there is also a relationship to the usage of this data for both input and output. So we find this in the Citizens Observatory web portal of the Citizens project, where we now are looking into the technology aspects as well as the user aspects from these perspectives. We can actually bring this also into a broader interoperability architecture, and what we see on the top level here is this user interface boundary edge computing facilities of sensors, mobile apps, everything that provides input to the system. With the main goal of ending down in the repository, where the observations will be stored and shared and linked and represented in many different forms. But one of the reasons why we want to look at commonalities here is that we can introduce a number of services dealing with understanding of the concept definitions with ontology observations, how to support the tracking of the actual data use, how to do analysis for changes in terms of sequences of observations in certain areas, how we can deal with visualization, both mobile and web portals, how we can do quality assessment, how we can support species observation identification, how we can introduce social networking and game services, as we have heard about earlier this week, how we can provide notifications of certain events. So there is a number of useful services that can be actually introduced once we have a common representation form that can be shared among a number of systems and services, including processing services for different kind of analytics. And also making it available in different forms. The GEOS common infrastructure is trying to share environmental observations across a number of areas. So we see that we can actually look at a number of technical elements from the data on the repository level to the processing services, which will link up to the applications. So we have looked into applications earlier this week and how we can actually do observations. And we have also mentioned the approach of looking at common data models. One of the advantages of having interoperable representation is that we can introduce and start to realize a number of services using these data representations eventually in the future. So just a few of these apps that we have been working on that are relevant also for this biodiversity observation app, like biocaching and others we have talked about this week. Just to illustrate the commonalities. And here we see from the Citizens project, the Sensit app to describe observations of current situations in terms of air quality and other aspects such as acoustic comfort, the thermal index, where a citizen will be on a certain point and report on this. We can see it displayed on the map, and we can provide various kind of inputs together with sensor data that is providing actual measurements. We heard also about the City Air app earlier this week, where users can report on how they feel the situation is in a particular point of view, which is really very similar in principle for doing an observation of any kind, which fits nicely into this week's focus on, say, flower and hepatica observations. The point is to show the commonalities here, and what we are studying now is the data model behind this, focusing on the observation and the measurements and the various characteristics of an observation. So this is part of the data model from the Citizens project. I will not go into the details of this, but I will just show the ongoing discussions that is happening across a number of projects now. We heard from OGC and BART about the SWE profile for citizen science, which this is part of the discussion for. where again the focus is on the citizen science observations, the observations itself, the time of the observation, the position of the observation, and the associated data that is being collected. And in general, the only thing that is actually different between the observation is the data types of the collection and certain additional information that might be different for different kinds of observation. But there's a lot of things in common that would help us to share data models across a number of observation types. So this is a bit of the details of what these data models look like. It's still not consolidated across a number of disciplines, and that's one of the activities we hope to do this year, to find out what this model will be, so that it actually can both share data across different kind of observation, as well as have the opportunity to capture specialized data, because also all disciplines will have some special additions that will be a part of extension here. And this is all needed if you're going to share data in the broader community, particularly with GEOS. Here we see more detail of the GEOS common infrastructure and how different community portals, such as Citizens Observatory portals, can play a part of this and provide their observations into the broader community. We need also, in order to support semantic interoperability, to understand the meaning of the things that we observe and that we share, to be able to have common definitions of what is an observation, what is the element of an observation, what are the different characteristics that is common among all of these observations. And that means that we in the future will be able to have web portals or access points that provide data in such a way that we not only can look at it, but we can also understand the meaning of the data, because we have a shared underlying common model. So this is just a part of the Citizens Observatory web portal, which looks a little bit on the map to the right from what we can do in the GEOS portal. And we can go there to identify observations in different areas and retrieve it and present it in different ways. And one of the objectives is to not have just particular portals that are specialized for a certain purpose. They will be there as part of it, but we also want to have this broader community that can share things across. So this is a current activity in the community. I want to mention the European Citizen Science Association as an active part of this. And we also have the American activities called the Citizen Science Association and a similar one in Australia. So these three communities are currently also interoperating in terms of their activities. Just to make a little marketing of the upcoming event of the Citizen Science Conference that will take place in Berlin in May, where there will be focus and presentations and discussions and sessions also on all of these aspects, including the common data models. So that was what I plan to do now, to basically give you this overview of all of these activities around interoperability and common data models and sharing. And this is ongoing activity in the community, where the Hepatica Week actually is an interesting contribution, because it shows one relevant observation type, and it's a good example of data that we would like to share among us in different kind of forms, also introducing these concepts of interoperability and data models, as I gave a kind of high-level overview of now. So here is some of the contact points of the Citizens Project and my coordinates. And hope there will be some interested people in the community that will also be part of the future activities, looking at how all of these things can come together to improve the further interoperability of all of the observations that we do. Okay,
thank you. Yeah, thank you so much, Arne. That was a whole lot of information. But I think we captured the major points, even though we didn't go into all the nitty-gritty coding that it appeared to be coding. I know it wasn't, but you know, it's a complex system, and it's a complex system that you showed us. But I think you also demonstrated that there are solutions to this. But I have one question before we go on, and that is, I mean, you have been talking about Earth observations, using different sensors across different citizen science projects or citizens observatories. But we can also, when we be talking about this in the group of Earth observations, that it is really interesting to combine not only Earth observations with each other, but also with other kinds of information data like economics and statistics of different kinds. Have you considered this in your work of making it interoperable systems?
Yeah, this is a good point. This is why we are experimenting also with different representation forms. And in particular with the linked data and the movement on linked open data, we see interesting opportunities to do cross-connection or linking of data from different data sources, looking at what kind of identifiers can we use to match. Typically, geospatial or spatial-temporal coordinates is a good connection point for doing linking. And this is why we now are experimenting with linked data representation for doing this kind of cross data collection mappings. So we see that we have valuable information from this observation, but there is a lot of relevant related information that can be integrated or linked in different ways. And at least the linked data representation is promising to support it's the variety and variability part of big data, where linked data is an interesting representation form that we at least have on the agenda to experiment further on during this year.
Yes, thank you. Yeah, the reason why I brought up this is also because then we are talking about actually making use of the data when we combine the data in different ways, in different contexts. And that brings me to the next presenter, Christian Hüttich. Welcome to Hepatica Week.
Hello.
Hi. We will hear you. I will let you present yourself just in a second, but just to remind people what you're going to talk about. He's going to show us how we can use data like information about when we see the first liver leaf in climate change studies. So, Christian, let us hear what who you are and what you work with.
Yeah, hi. So I'm working for a German space company, Jenoptronic now, and we have quite a department dealing with environmental monitoring projects. And the main topics are wetland monitoring, phenological monitoring using optical time series data, and we start working with local authorities on regional climate change monitoring projects. And there also this My Season app fits very well. And in this little talk, I'll just present how we could, the app and the citizen science approach to foster ground databases that should and that have to be used for climate change indicator derivation and monitoring. And yes, should I start the presentation now or?
Yes, you can. Just while you are giving us the screen, I will just remind the audience about the My Seasons app. We were out just before we started this mini class. We were out demonstrating it in the forest live with the Hepatica nobilis, with the liver leaf, Leberblümchen and blåveis. And so you can watch these demonstrations as well if you want to try My Seasons. I highly recommend it. And now you will see Christian tell us how he is actually using the data that we can collect now in springtime. So Christian, go ahead.
Okay. I share the screen and I hope it works. Like this. So, can you see? Can you see the slides?
We see the slides there, but not in presentation mode yet.
Not in presentation mode, okay. Then I just try to do this. Okay. Give me one more second.
Yeah, that's fine. Well,
Sharing
okay.
the screen, and now like this. It's better now? Can you see?
We not in presentation mode.
Not in presentation mode, because I started it in presentation mode.
Okay, but can you, if you
Okay.
try to go through the slides, does it move? Yes.
Can you?
Yes, it does. So you can go ahead and do that in that mode if you
Okay.
like. If it's complicated to.
But you can see the slides because I just see the PowerPoint.
Yes, we see the slides.
Okay, then I just start now. And the audio is also good, so you can hear me quite well.
We hear you loud and clear.
Good. So I will take you on a little tour how we use citizen science and Earth observations for global climate change effects monitoring on a regional scale. So the key issue is that we have. Also, okay. So this is the My Seasons app, and the My Seasons app was developed to provide a little tool for citizens to monitor phenology. So the timing of the year when the flowers and all the plants are getting green and the green up starts. And this is a very smart, a very strong indicator for global climate change monitoring. So phenology is the study of the periodic plant and animal life cycle events and how these are influenced by seasonal and interannual variations. And there's a strong relationship to weather and climate, and there's also a strong implication on the local, national, and global economy. If you're taking in pollination, the forestry, so foresters have to deal with what are the future trees that I have to plant in the forest after cuttings. How is agriculture dealing with the green up and the seeding periods, and all these questions have to be answered, and one of the indicators is phenological monitoring. So the main applications are trend analysis, indicators for climate change analysis, and it's a strong planning tool for in the agricultural sector, and also for the for people. How do you say in English? Like allergy, that have allergic problems. So, and the main problem is why we are doing this, or why we also developed some citizen science tools for this, and this is the global temperature record in 2015. And you see here that there's the anomaly between, I don't know, more than 60 years, that the northern hemisphere is really affected by global climate temperature rise, and this is not just a global problem, it's a global phenomenon that you can also see here in this plot, that 2015 was the warmest year since the modern record keeping began in 1880. As analyzed by NASA's Goddard Institute for Space Studies, and it's just continuing. 15 of the 16 warmest years have been occurred in 2001, after 2001. And now I'm coming to the regional perspective. So this is a global phenomenon, but with local and regional implications. So you see here the area where I live. So now I am here. This is in the middle of Germany. It's a administrative district, and this global warming has really local impact. So, and if you see here the climate scenarios that we see here, even if you go further in time, it's getting warmer and warmer, and the vegetation is responding to that. And because vegetation is responding, we can use this information for measurement. And also there was some studies on terrestrial basis that we see here. The black elder which is one indicator for phenological monitoring here in mid-Germany, that there was a lengthening of the vegetation period measured towards an early start of the vegetation period, and there's a really strong relationship to temperature rise. And there was an extension of the whole vegetation period of 19 days since 1961 and 2008. So this, you see here the trend of the start of season, I guess, and that's a real measurable trend. So the problem is now that the station network that we have in Thuringia is quite messy. So it's not complete. It's really it's a like a network of volunteers that go out and measure the phenology on specific places, and it's not consistent in the area coverage. And there's a need for updating information on phenological measurements, and this is really increasing. So there's also a need for data on the terrestrial side. So the goal, what we have in an upcoming project on this is to develop an indicator set for climate change monitoring using Earth observation and phenological data. So the power of Earth observation is demonstrated here. So if you see this, can you see this? Can you see the animation here? Or
yes,
just me? Okay,
no,
great. So this is an animation of MODIS, a NASA. It's an optical temporal high-resolution sensor of NASA's Terra and Aqua satellites, and you see here that we have a global daily coverage of vegetation information. And this is all free data, and there's also a trend for automatization and operationalization in the processing. So this is given by or followed by the main players like the Google Earth Engine, and also data providers like the ESA Data Hub are providing daily updated data of the global vegetation distribution or vegetation state of the vegetation. So, and this information has to be downsized on a regional and local level to make it possible, make it useful for decision making. Coming back to our small little Thuringian region, where also lever leaves are growing a lot. I saw them a lot also in the last days. We have a clear goal, so to use all these daily MODIS, for example, MODIS and Sentinel-3 data to derive seasonal metrics from satellite time series that makes a consistent mapping of vegetation dynamics possible. And again, we have this example of Thuringia here. We are following an annual monitoring of vegetation trends, like start and the end of season. So for every year, we want to derive maps of start and end of season parameters that are really useful indicators for like aerial consistent vegetation monitoring. From the data side, we use MODIS to go back in time and start with Sentinel-3 to have the latest and also the future data covered. You see here an example of the start of season, all those brownish colors. You see here is the forest where with the needle leaf trees, you have a kind of an early start of season as a small phenological cycle there, but all these bluish patterns here, this is all agriculture and grassland and shrubland, which is starting later in the year. So this is a really sensitive parameter for mapping the phenological dynamics for different land cover types. And how it is done. So it's done by taking daily or weekly measurements of vegetation activity data over, for example, here for MODIS for the last 15 years. You see an up and down. In the winter, there's no activity. In the summer, it's going up. And we have methods how to derive a threshold when the season starts. So this is indicated here by the by those little dots, and you see for every year we have a measurement from space. And we can derive different kinds of maps, like the start of season for a whole region. This is just cut for forest areas here, and the end of the season. So you have different land cover types, you have different timing of the phenological behavior. And yeah, the problem or the challenge is now, how can we validate and strengthen this information and make it, how can we convince the authorities on a regional, on national level to use this huge information for decision making and fostering or supporting, consulting all the economy around. So, and therefore we use the citizen science approach. For example, this My Seasons app here. So the goal is just to optimize the observation network for phenological observations, to increase the understanding of long-term vegetation trends by controlling comprehensive ground observations, and also to raise awareness. So, because climate change is not just a exciting scientific study area, it's just around you, so you can see it, feel it every day and every year. So, and this is a nice helper on your smartphone how to capture those data, and it's just to go with open eyes through your landscape, and you can derive scientific valuable data. So all these data can be stored in a database. There's also planned to do a next like a next version of this app where you can create campaigns. So you can, if you have interest in a specific species like the leather leaf or like the apple tree, so you can derive a specific campaign for this specific species, and we can also communicate this with the local authorities that they can use this data for those analysis, and also to validate and calibrate and validate Earth observation techniques. So this was it from my side, more or less. And if you have questions, just come back to me, and this is the URL for the app. Just download and test.
Yeah, thank you so much, Christian. And I can really vouch for the high degree of usability of the My Seasons app. It's really very simple. So anybody, just anybody, children can also play with this application. And so that's for sure. But I have a question for you concerning, and then of course our lovely spring flower, my favorite, the Hepatica nobilis or liver leaf. Is it so? I mean, it's very hard to see. Yet we don't have a satellite technology that will see each individual flower, of course. Do you see that our observations of the arrival of the liver leaf can complement or strengthen or improve the quality of the other indicators? I mean, the liver leaf is one of the definitely here in this part of the world, up in Scandinavia. It's a very clear indicator to us. You know, we have this competition when we are children to go and find the very first flower. So it's immediately after the snow has, melted. So on a personal and on a very small scale level, that's for sure an indicator of spring, in among people. Is it so that you can use that also combined with the other kinds of indicator? You said that you would define indicators. How do you see this linked?
So, of course, all those different individual observations can help to refine also the space-based methods. So, of course, we cannot see with a coarse 250 meter pixel, we cannot see the plants. We cannot directly link the satellite signal with the green up signal of a specific species on the ground, but we have to collect ground truth data to to validate the time series analysis techniques for phenological models. For this example here in Thuringia, we have the problem that the observation network is quite scattered, and we need a better sampling scheme. And the more data we have from different locations, the problem also is that the climate stations are not really representative for a pixel. And for example, if we give the app to you and your family, and you collect, I don't know, 100 points in 5 minutes, then we have a much better sampling scheme. Yeah? And if you do this every year, we have a really powerful and sensitive database for parameterizing the model a little bit. And this is, this is a really important data source. But of course, the message that the phenological map is giving us from satellite perspective is not the same. But the advantage is that we have a large area, and we can measure the climate change effects on a regional level. So, but
Yeah, so what you say is that the more ground-based observations we have, like when we take pictures with our mobile phone, that will actually support your work in seeing the change or the effect of climate change.
Definitely, yeah. It also it's not only supports the work of like remote sensing activities. It also supports work of for example, the weather services. They have to provide services for agricultural applications and forestry applications, and they have to do recommendations. And this is really powerful information for them, because the main problem is that you have a network of volunteering people going around every year, and they have a kind of agreement that they measure phenology, but the citizen science approach is not really used in this field. So, and also our contacts from the German Weather Service, they are really hopeful and are looking really positive in the future to use those technologies for intensifying or to optimize the database a little bit. Yeah, but this is just, the standard point of view, from the standards point of view, it's a little bit a problem, because every human being is seeing the flowering a little bit in a different way, so we cannot follow a specific standard on the observation. But the more people we have, the more meaningful is the database at the end. But that's a new playground for statistical things. But of course, every measurement is helping us, and also the weather services.
Right. So what you mentioned there, by the way, is that, like what Arne just told us about making the data interoperable, you are linking in your answer, you're linking our observations of the flowers, or the tree, the apple tree, or you have a series of species in the My Seasons app, and having a system in place to combine it with weather data is something that Arne then can help with, right, Arne? That's an example of what you are doing, right?
Yeah, no, this is where we see the opportunity of bringing data from different sources together and to do combinations, so that different kind of analytic processing can be run against this. So that's where citizens' observations offers a very important additional data source that will be very point-oriented and timely. Of course, there's a lot of interesting aspects also on uncertainty and the veracity or the quality of the citizens' observatory data, and the validation processes and other aspects to this. But I think we are moving towards a future where all of this will be brought closer together and be all important parts of the bigger picture.
Absolutely. So thank you so much for your presentations. And I think you see now very clearly that, in fact, what we do with our mobile phone, taking a picture and sending it via My Seasons app or any other applications, or even through the internet, as you saw yesterday, we can also upload our pictures on the internet and turn everything into scientific data. And Christian showed us that this, in fact, is very useful for science and other applications. So with that, I will then, we are almost through with the Hepatica week. There is one last presentation that will take place a little bit later this evening here in Norway, a bit further into the day in the US. And that is more going even deeper into the relationship between space and our lovely flower. It's a presentation called Citizens Data for Validation of Satellite-Based Data and Services. And you will see that there are even more useful applications for society that we can help with citizen science and the My Seasons app. And in addition to that, you will learn more about also the European citizen science associations, because you are just seeing a little bit this week of what you can do. If you think that contributing with your observations is interesting for you, there are many, many other options as well in many different areas. There are a huge number of citizen science projects within biodiversity only, but there are weather possibility to support weather forecasts, astronomy, and even using your computer. So if you are interested in contributing in one way or another, there's tons of opportunities. And do follow us here on Hepatica Week, hashtag Hepatica Week, and I will share you my screen so you can make some notes here if you are interested. You see here the program, and I will do like this. No, I was like this. Oops. Yeah. So you see that if you follow @PlanetBy on either Twitter or on Periscope, you will stay informed about what's going on. There will be more activities, and by following PlanetBy, you will be sure to be alerted. You can also sign up for more information on one of the Facebook pages called Hepatica Week. So I hope that, let me see now, I will go back to my face. Thank you so much for attending this. Thank you so much for the presenters for very interesting presentations. And go and check out the hashtag Hepatica Week, and you will be able to learn more about space and citizen science in just a couple of hours at 9 o'clock Central European Time and 7 o'clock UTC. So thank you so much, and see you again soon. Bye-bye.
Bye-bye. Thank you.
Thank you.
Bye.
Bye-bye.